So this is video number 3, and we are going to get into why we use long division and how it can help us find imaginary roots. So let's take a look at this given polynomial and its graph. So if we wanted to come up with all of the roots here, so remember that since this is a degree 3 polynomial, there are actually 3 roots to this graph. Now, when we look at the graph, all we see is 1, okay, because there's only one real root. Okay, so there's one real solution here, and then there's going to be 2 imaginary solutions that we can find. So what we're going to do is we're going to take this real root and we're going to divide it into this polynomial. So remember, if the root is 2, then the factor that goes with that is x minus 2. So what we're going to do is divide this polynomial by x minus 2, which will help us get down to a quadratic equation, which then we know how to do quadratic formula or factor if we can to find the rest of the roots. When they're imaginary, you'll have to do quadratic formula for the most part. So let's divide this in using long division. So what times x gives us 2x cubed? So that's going to be 2x squared. Multiply it and we'll get 2x cubed. 2x squared times negative 2x is going to be negative 4x squared. Then we need to subtract. So 2x cubed minus 2x cubed is 0. Negative 4x squared minus negative 4x squared is 0. So we'll carry down this next term. Okay, and then so now we're going to be kind of missing a term because the x squared's canceled out. That's fine. Okay, so what times x gives me 2x? Well, that's going to be 2. Okay, plus 2. So then multiply. So 2 times x is 2x. 2 times negative 4 is negative 4. And we can just carry this down. Okay, then you're going to subtract. 2x minus 2x is 0. Negative 4 minus negative 4 is 0. That's good because this is a root. Okay, it is a factor. It's a real solution here. So we shouldn't have a remainder. Okay, so what we've done now is factored this polynomial. So now we know that this polynomial actually factors down to x minus 2 times x squared plus 2x. So when we set this equal to 0, we solve for this root. So now we're just going to do the same thing with this and solve for when that equals 0. So when the other root equals 0. So 2x squared plus 2 equals 0. So this one you don't have to use the quadratic formula because you're down to just an x squared without an x. So we can just isolate it. So subtract 2 from both sides. Divide by 2. And then square root. Remembering when you square root, you get both a positive and a negative root. Okay, so when you put in the square root, you get both a plus and a minus solution. And then the square root of negative 1, we just call I. So our roots that we just got here are plus or minus I. So the 3 roots that we get for this polynomial, we saw the real one on the graph was x equals 2. And now we just solved for I and negative I. So that gives us 3 total roots, 1 real one and 2 imaginary. So this next graph is a quartic function, so a degree 4. So there should be 4 total roots. Okay, so we can look at the graph and see the real roots here. Okay, so we have 2 real roots of x minus 6, of negative 6 and 1. So what we want to do is write those as factors, which is really x plus 6 and x minus 1, so that we can divide those into this polynomial. So now I don't want to have to divide twice, so I'm actually going to multiply these out so I can divide by them at the same time. So x times x is x squared, x times negative 1 is negative 1x, and 6x here. So negative 1x and 6x is 5x. 6 times negative 1 is negative 6. So I'm just going to divide this polynomial by both of these at the same time. Versus having to do it twice. Okay, so what times x squared gives us x to the fourth? So that's x squared. So now you're just going to multiply this by all three of these terms. So you'll get x to the fourth, 5x cubed, negative 6x squared. Then you'll subtract them. Okay, and just be careful that you subtract all of them. So then you end up with 0. 11x cubed minus 5x cubed is 6x cubed. 34x squared minus negative 6x squared is plus 40x squared. And then carry down this next term. Start over. So what times x squared gives you 6x cubed? Well, 6x. So 6x times x squared is 6x cubed. 6x times 5x is 30x squared. 6x times negative 6 is negative 36x. Subtract. 6x cubed minus 6x cubed is 0. 40x squared minus 30x squared is 10x squared. 14x minus negative 36x. Okay, that's what, 50x? And then carry down the negative 60. Start over. What times x squared gives me 10x squared? Well, 10. So 10 times x squared is 10x squared. 10 times 5x is 50x. 10 times negative 6 is negative 60x. That should happen. That all of these are identical so that when you subtract them, you get 0. Because these were zeros. These were solutions. They were factors. There should be no remainder. Okay? So now what we get is when we factored this out, we have this other polynomial here to find our zeros. So we already know that this one is x plus 6, x minus 1. Okay, so we have those two zeros, x equals negative 6 and x equals 1. Now what we need to do is figure out what zeros go along with this part. Well, this isn't factorable. Okay, that's why you don't see them crossing anywhere. It's going to be imaginary. Okay, so we're going to take that quadratic, x squared plus 6x plus 10, and we'll have to do the quadratic formula for this to find our imaginary roots. So that's the opposite of b. So negative 6 plus or minus b squared minus 4 times a times c all over 2a. So I'm going to simplify what's underneath this root right here. So that's 6 squared is 36. Negative 4 times 1 is negative 4 times 10 is negative 40. So we have negative 6 plus or minus the square root of negative 4 divided by 2. So we get negative 6 plus or minus. Square root of negative 1 is I, and square root of 4 is 2. So we get 2i here, divided by 2. All of these are divisible by 2, so we'll divide by 2 to everything and get our two imaginary solutions as negative 3 plus or minus I. So our original two solutions were negative 6 and 1. Those are our real solutions. Then we have negative 3 plus I as a solution and negative 3 minus I as a solution to give us our 4 total solutions to this quadratic, or this quartic, this x to the fourth. Then another way you can use long division is like on this one where we see all 4 roots here, okay? But we only see 2 roots that are rational, that have actual whole number values, or are decimals that we recognize. So these 2 right here are actually irrational. So if we needed to write them in exact form, we would need to do long division here. So our 2 solutions that we can see on the graph that are nice are -3 and 1, meaning x plus 3 is a factor and x minus 1 is a factor. So we're going to need to do long division. So I'm going to multiply these out first. So x squared, -x and 3x is plus 2x. And then 3 and -1 is -3. So we're going to divide that into our original polynomial, which is x to the 4th plus 2x cubed minus 6x squared minus 6x plus 9. So do long division. So we're going to do x squared, because x squared times x squared is x to the 4th. X squared times 2x is 2x cubed. X squared times -3 is -3x squared. Subtract. So we'll get 0, 0. -6 minus -3 is positive 3x squared. Carry down this next term. And since one of them canceled out, we'll also carry down the next one. Start over. What times x squared gives me 3x squared? Well, that's 3. So 3 times x squared is 3x squared. 3 times 2x is, oh, sorry, I missed this. Okay, so what I'm seeing here is when I multiplied this, I got positive 6x. These need to exactly match since these were roots, and they weren't exactly matching, so I must have done something wrong in my math. So when I look here, it was this negative. So when I did -6 minus -3, this should have been -3x squared. Okay, so if that was -3x squared, then I actually needed to multiply by -3 for those to match. So -3 times -3 times x squared would be -3x squared. -3 times 2x is -6x. -3 times -3 is plus 9. So if your math isn't working out, trust it. Go back and look and see if you made a mistake. All right, so then all of those match. So when we subtract, we get 0. And so then this is the leftover polynomial here after we divide those in. So now we just need to set this one equal to 0 to solve for those irrational roots. So we'll do x squared minus 3. This is nice since it's just an x squared. We don't have to do quadratic formula. We can just add 3 to both sides. And then square root, remembering the plus and minus root. So then plus or minus square root 3 are our other 2 zeros. Okay, just irrational this time. So our 4 roots in this case, we had all 4 are real, okay, but we had these 2 rational roots, -3 and 1, and then we also had 2 irrational roots.